Thematic focal point, bringing damage to your burrow. We some brothers from the east with them beats that be thorough. Got the solar gravitation, so I'm bound to pull it. I gets down like brothers have found.
Okay, so this one's a little bit tricky because as we see on the bottom, there's only, well, basically, there's not like a series of parentheses because usually we're used to seeing like something times something, right? But this one, first of all, it's not reducible, so it's irreducible, which means that we're going to have some kind of linear form on top, right? But anyways, let me introduce a little trick that I have. So we have our x squared on top, and then let's say we want to create parentheses, right? So what can we do is ones come in handy a lot. So let's say we have a 1 down here, and then it's added to a 0x, right? So that's essentially just 1 on the bottom, which is basically the same thing that they gave us, right? So here we're kind of finding a loophole so that we can make it a fraction. So here we're going to have, when we rewrite this, we're going to have something over x squared plus 3, and then plus something over x, 0 times x plus 1, right? And then times the dx at the end. So over the irreducible one, the irreducible quadratic, we're going to have some kind of ax plus b. But then over this one, this is actually linear because it has only x raised to the first power. So we're just going to have one variable over it. Okay. Alright, so now let's proceed and we'll do the trick where you like cross multiply in a sense. So we're going to take the numerator here and multiply it times all of the denominators except for the one it's over. So this one. So we're going to do 0x plus 1. And then we'll do the same thing with c. So we're going to take c and multiply it times the other denominators. So that just includes x squared plus 3. Okay? And then we're going to set this equal to the given p of x. So the thing on top. So that in this case was x squared, right? So this is going to be a 1, right? 1x squared plus 0x plus 0. We can just consider it like that. Okay, so let's simplify. And we have ax, well, 0, ax squared plus bx, there's a 0 in front of that. So we just get ax plus b. And then we have a cx squared plus 3c, right? And then on this side we have a 1x squared plus 0x plus 0. Okay, so what we have here is a 0, well, this is 0, and this is also 0, so we can neglect those. And when we compare the coefficients in front of the x squared terms, we get that c is equal to 1, right? And then we also get that ax has to equal 0x, right? Hold on here. Okay, so this ax, again, that equals 0x, so a has to equal 0. Alright, and then our b, so we can make an equation with the constants, right? So the constants on the left are b plus 3c. 3c equals, constants on the right add up to 0. And then, so if we plug in 1 for c, then we get that b equals negative 3. Okay, so we're going to plug in these three numbers, a equals 0, b equals negative 3, and c equals 1, into this equation right here. Alright, so I will do that on the next slide. Okay, so we're going to get that, okay, so ax plus b was 0x minus 3 over the first thing, x squared plus 3, and then plus c, which is 1, over 0x plus 1, which is 1, and then our dx. So this equals a negative 3 over the denominator plus 1 and dx. I'm just going to break this up into two separate integrals so we can work with them separately. So we have a negative 3, I just brought that out, over 1 x squared plus 3 dx, and then plus just a 1 dx. Okay, So then this, it might not look very nice right now, but if you rearrange it, so if you reformat it like this, so if I were to take out a 1 over 3, then I have, let's see, hold on. So then I have an x squared over, oh wait, actually, go back. Sorry. One moment here. That isn't a 1 over 3. That's a 3. If I take out a 3 out of the bottom, then we actually get x squared over 3. There we go. And then a plus 1, right? And then our dx. Okay, so then these 3's can actually cancel. And we also have this at the end there. Okay, so this simplifies to this 1 over, and I'll rewrite it in a different form, over square root of 3 squared, right? That's equivalent. And then plus our 1 dx. So by now this should look very familiar as equaling the arctangent of x over radical 3. Okay? So I'll continue writing this on the next page. Okay. So we're going to get a negative inverse tangent of x over root 3. And then the integral of 1 was just x. And then since we're integrating an indefinite integral, we have to have the plus c. Okay, so that's all for this question, and I hope that helps.